Okay. Okay, so we're doing chapter 1. And we're doing, first, index laws. Simplify 3x squared. So that's 15x to the 6. (15x to the 6) is the simplification of 3x squared times 5x to the 4. Simplify 12x to the 7, 4x cubed. The answer is 3x to the 4. So 3x to the 4 is 12x to the 7 over 4x cubed. Simplify 2x cubed all to the power of 4. The answer is 16x to the 12. Sixteen x to the 12 is 2x cubed all to the 4. Simplify 3a squared b times 4a cubed b to the 5. The answer is 12a to the 5b to the 6. Twelve a to the 5b to the 6 is 3a squared b all times 4a cubed b to the 5. Simplify 2x squared all cubed over 4x to the 5. So taking care of the numerator first, that's 8x to the 6, and then 8x to the 6 over 4x to the 5 is 2x. So 2x is 2x squared all cubed over 4x to the 5. Hello. Okay, next. Expand x plus 3 all times x minus 7. The answer is x squared minus 4x minus 21. So x squared minus 4x minus 21 is the expansion and simplification of x at 3 times x takes 7. Expand and simplify 2x take 5 all squared. The answer is 4x squared minus 20x plus 25. So 4x squared minus 20x plus 25 is the expansion and simplification of 2x minus 5 all squared. Expand and simplify 3x add 1 times 2x take 3. Is that right? Yes. Expand and simplify 3x add 1 times 2x take 3. So the answer is 6x squared minus 7x minus 2. 6x squared minus 7x minus 2 is the expansion and simplification of 3x add 1 times 2x take 3. That's wrong. Okay. Expand and simplify 3x add 1 times 2x take 3. Six x squared minus 7x minus 3. So 6x squared minus 7x minus 3 is the expansion and simplification of 3x add 1 times 2x take 3. Expand and simplify 3x all times 2x take 4, take 2 all times x squared take 5. Alright, try again. Expand and simplify 3x all times 2x take 4, take 2 all times x squared take 5. Four x squared minus 12x plus 10. So 4x squared minus 12x plus 10 is the expansion and simplification of 3x all times 2x take 4, take 2 times x squared take 5. Okay. Okay. X plus 2 times x minus 2 times x plus 1. Okay, so expand on the first two brackets using the difference of two squares. So it will be x squared minus 4. And then multiply x squared minus 4 by x plus 1. And we get x cubed plus x squared minus 4, x cubed plus x squared minus 4x minus 4. So x cubed plus x squared minus 4x minus 4 is the expansion and simplification of x add 2 times x take 2 times x add 1. Okay, next. Factorizing. Factorize x squared minus 9x plus 20. The answer is x minus 4 times x minus 5. So x minus 4 times x minus 5 is the factorization of x squared minus 9x plus 20. Factorize fully 9x squared minus 49. The answer is 3x plus 7 all times 3x minus 7. that's wrong. Try again. Alright, factorize fully, 9x squared minus 49. The answer is 3x plus 7 multiplied by 3x minus 7. So 3x plus 7 times 3x minus 7 fully factorizes 9x squared minus 49. Factorize 6x squared at 11x minus 10. So the answer is 3x minus 2 times 2x at 5. So 3x minus 2 times 2x at 5 is the full factorization of 6x squared at 11x minus 10. Factorize fully 2x cubed minus 18x. So first we factor out 2x. So we get 2x, open brackets, x squared minus 9. And then we apply the difference of two squares. So we get 2x all times x at 3 times x minus 3. So 2x times x at 3 times x minus 3 is the full factorization of 2x cubed minus 18x. Factorize fully x cubed at 2x squared minus 15x. We factor out x to get x all times, x squared at 2x minus 15, and then we factorize the quadratic into x at 5 times x take 3, and so it becomes x times x at 5 times x minus 3. So x times x at 5 times x minus 3 is the full factorization of x cubed at 2x squared minus 15x. All right. So we now have negative and fractional indices to deal with. Evaluate 16 to the 3/4. 16 to the 1/4 is 2. So 16 to the 3/4 is 2 cubed, which is 8. So 8 is 16 to the 3/4. Evaluate 27 to the negative 2/3. So first we must do 27 to the 1/3, which is 3, and 27 to the 2/3, which is 9, and then 27 to the negative 2/3 is 1/9. Evaluate 8 over 125 all to the negative 1/3. So 8 over 125 to the 1/3 is 2 over 5, and 2 over 5 to the negative 1 is 5 over 2. So 5 over 2 is 8 over 125 all to the negative 1/3. Write 5 over root x in the form k times x to the n. That would be 5 times x to the negative 1/2. Solve x to the 3 over 2 equals 27. Raise both sides to the power of 2/3. Then x is equal to 27 to the 2/3. And thus x is equal to 9. So the solution to x to the 3 over 2 equaling 27 is 9. Alright, now we try surds. Simplify root 75. Root 75 is root 25 times root 3. And root 25 is 5, and thus root 75 is 5 root 3. So 5 root 3 is root 75. Simplify root 48, take root 12. Root 48 is 4 root 3, and root 12 is 2 root 3. So root 48 take root 12 is 4 root 3 take 2 root 3, which is 2 root 3. So 2 root 3 is root 48 take root 12. simplify root 8 times root 6. Root 8 times root 6 is root 48, and root 48 is 4 root 3. So 4 root 3 simplifies root 8 times root 6. Expand and simplify 3 plus root 5 times 2 take root 5. Okay, so just setting up a multiplication table here. We have, let's see now, alright, so just give it a second. We have 1 take root 5. One take root 5 appears to be the simplification of 3 plus root 5 times 2 minus root 5. Hello! Expand and simplify 2 root 3 take 1, all squared. Okay. So what we do is we do 2 root 3 times 2 root 3, which is 12. And then we have 12 take 4 root 3, 12 take 4 root 3, plus 1, which is 13 take 4 root 3, 13 take 4 root 3, take 4 root 3 is the expansion and simplification of 2 root 3 take 1 all squared. And finally, we have rationalizing the denominator. Rationalize the denominator of 6 over root 3. Timesing the top and the bottom by root 3, we have 6 root 3 over 3, which is 2 root 3. So 2 root 3 rationalizes the denominator of 6 over root 3. Rationalize the denominator of 4 all over 2 take root 2. Multiply the top and the bottom by 2 plus root 2. And we have okay. Two on the denominator and 8 plus 4 root 2 on the numerator, and thus 4 plus 2 root 2. Four plus 2 root 2 rationalizes the denominator of 4 over 2 minus root 2. Rationalize the denominator of 1 over root 5 minus 2. Multiplying the top of the bottom by root 5 plus 2. So we have root 5 plus 2 all over 1. So it's root 5 plus 2. Root 5 plus 2 rationalizes the denominator of 1 over root 5 minus 2. Rationalize the denominator of root 3 all over root 3 plus 1. Okay, so times the top and the bottom by root 3 minus 1. And what we have on the bottom is 2, and what we have on the top is 3 minus root 3, 3 minus root 3, so 3 minus root 3 all over 2. Three minus root 3 all over 2 appears to be the rationalized denominator version of root 3 all over root 3 at 1. And finally, rationalize the denominator of 10 over root 3 plus 2. No, try again. And finally, rationalize the denominator of 10 all over 3 plus root 2. So times the top and the bottom by 3 minus root 2. And on the bottom we get 7. And on the top we get 30 minus 10 root 2. So 30 minus 10 root 2 all over 7. Appears to be the rationalized denominator version of 10 over 3 plus root 2. Okay, but this time we must actually check. Whereas before I did not have this feedback mechanism strong enough. So now I'm going to implement it more rigorously. Oh no, there's actually a genuine error there. Great. so 29 out of 30. Certainly not bad. That's it.